So here's where we left it. Circle class, we made it a child class of the ellipse class. The constructor just called super. That's the constructor for the super class. In this case, that's ellipse. The draw method, we're relying on kind of an old version of Java. They have an older library that draws ovals, so we figured we'd just use that for our drawing. And then biggest difference between a circle and a ellipse is that it has a radius. So we added that method. And also for our getx and setx, getY and setY, we decided to move our placement or our origin for our shape to the middle of the circle. That seemed to make more sense. So all the other ones use the top left-hand corner, whereas a circle would use the center of the circle to position it on the screen. So we did some fanciness there in the circle class. But today's topic is the Isosceles Triangle class. Say we have to draw one of those. Let's take a look what's involved. Do that, I'll do that. All right, so isosceles triangle kind of looks like this, right? Could be any, any height really. But the key feature of an isosceles triangle, anybody know what the key feature is? What kind of differentiates it from other just regular triangles? Yeah.
Isosceles has two long sides and a short side.
Right, and the two long sides are the same, okay? The base can be any width, the height can be any size, but the isosceles triangle has two sides that are the same. Not three like an equilateral triangle, but just two. We're going to start with that one and then we'll get more fancy. Well, why is this easier is the question. Well, how do we place it on the screen? What should we use? Is there a center of the isosceles triangle? Not really. I'm sure there is one, but I suppose if you bisected these and you'd come across some point, maybe it'd be the center, but it wouldn't be a great placement idea. We look at our other shapes to see how similar it is. We know that rectangle and square is just a rectangle with all four sides the same. So it's kind of similar to that, but when we're trying to place it, we've been using this top left hand corner to put our shapes on the screen. So can we do that with the triangle? And the answer is, well, if we imagine a bounding rectangle, would we have enough information to draw it if we had this coordinate, xy, and the width and the height of the bounding rectangle? Could we determine all the 3 points of our triangle so that we can draw it? What do you think? Do we have enough information? Well, can we determine what this is, right? Say, what is this point? Because, again, a triangle has 3 points, right? And we're trying to figure out, well, how do we calculate this one point? Well, it's simple. I mean, we have the width, we have the height. So we could just say, for x would be x plus width, right? So x would be pretty simple for that point. For y, well, y plus height. So we can calculate that 1 point pretty easily. We just add the width and the height to x and y, and now we have that point. Here's another problem. What's the coordinate of that based on this xy? What would x be? Anybody? X. Yeah, x is the same, right? Because they line up. What about y? Yeah, y plus height again. So we can calculate that one too based on this bounding rectangle idea. How about this one? What do you think that would be? This is a little harder. Well, yeah? Yeah, that's right. So x plus width times 0.5, let's say, do it that way. And that'll get you the midpoint of that line. Now we could go through all the geometric proofs, Euclidean geometry, things like that, to prove that, yeah, that's bisecting that line. We haven't really proved that, but I think we can use that because we generally understand that. I kind of like going through the old proofs, so I'm actually, there's this book written by Euclids called Euclids Elements, and it was written way back when, like 500 BC or something like that. And he proves all these geometric shape ideas by using just two compasses, a straight edge, and pencil. He doesn't use anything else. No measurement devices at all. Just two compasses, a straight edge, and a pencil. And with those three different things, he's able to create a whole set of books, all on geometry. So if you ever have a chance to look at that, it's actually kind of fun. So now I think we can calculate all the points. Y would just be y, of course. So now that we can identify the 3 points of the triangle, the question is, how do we code it? I mean, it's fine to know all the coordinates and everything, but how do you actually do this? Well, we're missing a few elements. And there's two elements we're missing. One is a point element. We really don't have that yet. We have these shapes, but we don't really have some way of specifying a point in our xy coordinate space. Another thing we don't have is a line. Okay? Rectangles are easy, and Java has a class for a rectangle, so that's easy to draw. But it doesn't really have a triangle class. If you look through the Java libraries, there's no triangle class, which means that we're going to have to create our own triangle class. What are we going to need to create that triangle class? Well, we're going to need to have some concept of a point and some concept of a line. So we look at our inheritance hierarchy and we go, okay, where should the line be? I guess the first question is, would it be on the bottom? Is a line a square? No. Remember the is-a test? The child should be a type of its parent. So a square is a rectangle. Is a line a square? Well, that's kind of, if you had a square or a rectangle perhaps with no height, you can make it look like a line, but again, that's pretty contrived. So you're trying to shoehorn that into a rectangle. That's not really a good idea, I don't think. So a line doesn't really fit here, for circles and ellipses. Is it a type of regular polygon? I guess it would be a polygon on one side. Not really there either. So is it a shape 2D? Well, shape 2D has a width and a height and an x and a y. Does a line have that? Does it have a width and a height? No. Lines just have a length, basically. So it looks like our lines then are separate from even shape 2D. We're going to have to write a separate class for doing our lines and our separate class for doing our points. Now we could just use the lines and points that are available in the Java library, but again, I think the way Java does it, the inheritance hierarchy is not ideal, at least conceptually. Maybe functionally it is based on the limitation of Java, but I'd rather have a more abstract, more accurate depiction of these shapes. So today we're going to take a look at two classes. One will be our line 2D. Is it two-dimensional? Let's just call it line. And then there's a point class. And we're going to create those classes today. So if you could open up your project in NetBeans, and we get started on trying to create this point and line thing and talk about what instance variables belong to these types of shapes. Okay, so we're going to create a new class. So just right-click on your package name, say New Java Class, and we're going to just call this line. Well, let's start with point, actually, because we need 2 points to create the line, I guess. Okay, let's talk instance variables. For a point, what do you need to know? Yeah. Oh, yeah, sure, sorry. I thought I did that. Of course. Not awake yet, sorry. Okay, so here's our class then. We know that with points, basically they really don't have a dimension. They're just a single point in most graphic libraries. So all we really need for a point is an x and y location, right? Now we don't want all the other baggage that comes with shape 2D. So basically we can say this. We can say int x comma y, right? We'll make these private. We also want to do get and set methods for these two fields. So we go up to our refactor menu item, select that, go down to encapsulate fields, and it sees our x and y and it says, do you want to create a get and set functions for those? We say, yeah, we want to do that. And then click on refactor. That creates our accessors and mutators. The only other thing we need really is constructor. So we public, and then remember with constructors there's no return value. You just do that. Here's the default constructor, and say for the default we set x and y to 0. So if you don't know the position of this point quite yet, but you still want to create the point in memory, you can do that. And again, another form of the constructor where we'd pass in construction parameters. So this would be int x, int y. Yeah, so this is really basic class. There's really not a lot going on here. We just have a couple instance fields, x and y. We have accessors and mutators. We have 2 constructors. The question here then is, do we need a draw method? That's a good question. Do we need to have a way to draw this stuff? We'll be drawing points, probably so. But let's leave it out for now, and we'll go from there. Is this anyone's flash drive? Somebody left it, probably from Game Design 2 last term. It's white. It's got blue, 16 gigabytes, so it's nice. Okay, I'll keep asking in all my classes. So now we have a point class. See, that wasn't very hard, right? Point class, pretty simple. Okay, your job today, at least for the next 10 minutes, is try to create a line class. Okay, what does a line class need? How do you define a line? So I'm going to give you about 10 minutes, and I'd like you to try to create for yourself your own line class. When you're doing this, you have to think, okay, to draw this line, what information do I need? Also, we just created the point class, so you might think about perhaps using that to help define what your line's going to be. To draw a line in the screen, what do you need? So think of it from a need standpoint, and you might be able to get to a point where you'll be able to draw that line. So I'll release your screens, and you can try that for a while. And now we can focus in on the constructors. So public line. The line will take 2 parameters. Again, it's the same pattern. We take the construction parameters. Those have the names P1 and 2. We take that and we store that into this object's P1 and this object's P2. We have to use the keyword this because we have to differentiate between this P1 and that one coming in. So when you say this.P1, what that means is this private point is the one you want to set. Another form of the constructor would be the default constructor. And this is where it gets a little bit tricky. We could say public line, no construction parameters. And the question here is, what do we set P1 equal to? Well, right here in the constructor, we can create a kind of an empty point. So we could say new point. And what that constructor is going to do, the points constructor is going to set the x and y to 0. So I suppose that's okay. And again, we call the default constructor. So what you'll end up is with 2 points, but both points will be at 0, 0. Not much of a line. But when you have to create a lot of lines, this might be a nice way to do it. So we've got our points, we've got our lines. What do we need to do with our lines? Well, our goal, again, if you remember from the beginning, is we're trying to draw a triangle. And so to draw a triangle, you need to be able to plot points, but you also need to be able to draw lines. So our line method, or our line class, is going to need a draw method. So let's do that. We'll add a draw method here. If we look at our say maybe rectangle, we can borrow this function heading. And we're going to put that in our line class. So maybe right here would be a good spot. It sees we're using Graphics 2D and asks us if we want to import it, and we say yeah. And then we need to look at the Java library. So we see this one here. It's abstract though. I wonder why it's abstract. We'll see what it can do then. So we're using Java's line class. And now we want to create one. So we can say line equals new line 2D. This is getting kind of cumbersome though. It'd be great if we imported this so we don't have to keep typing it in again. Since we have a different name, ours is called line, it's called line 2D. I'm going to copy that and we'll add it to our input ports up here. And that gives us that import. And what that allows us to do is to get rid of all this stuff. That's called a fully qualified class name. And again, I get tired of typing that in because we're going to have to type that in a few times. So I just added the import up at the top, and that allows me to be a lot less coding right here. And we'd like to pass in the constructor for that, but it didn't really give us a set of constructors. So let's see what line 2D has. It has a choice whether you want to use doubles or floats. We're going to use doubles. Suppose we want to make this, well, I'm kind of leaning towards floats because we're going to try some fancy things. So let's just go with float as our data type. That's a real number. It doesn't have the same precision as a double, but it's a little bit smaller. Notice it has a lot of different constructors. They have the default constructor. It takes 0.2Ds, that's interesting, or 4 floats for x1, y1, x2, y2. So why don't we use that one there? So here we would say we'd say get p1 dot, we want to call get x Yeah, so this line gets a little bit complicated. So what you're saying is go get the first point, and once you have that first point, go and get the x for that point. That's a lot to do in one line, so let's just break it up a bit. Let's call this int so we're going to do this in stages. Let's do it this way. And what we'll do is we'll go get that point. And we'll do this in separate steps. Just makes it a little bit easier to understand. So that'll go and get those 2 points out of so I'm looking here, I'm going, well, the mistake I'm making here is I'm making it too complicated. Because point 1 and point 2 are down here, and they're freely accessible. And so this is really overkill, where you're calling the accessors to get access to things you already have access to. So we can simplify this then. Sorry about that. Get rid of those 2 lines, but then here we can just say P1. That's a lot simpler. And that's okay in object-oriented programming. You can, if you have private access, you're inside the class for drawing a line. You can just type in P1. And again here, P1 dot get Y. Then we do it again. Oh, this is a P2 this time. Yeah, so it looks something like that. So we have our line now, and we want to draw it. So we say G2 dot draw. And see here it says shape. There doesn't seem to be one specific to this, like a draw line method. We could say line and see if that works. Let's see if it compiles. Yeah, it looks like it works. Okay, so let's then go to our driver, see if we can draw a line now. Okay, so to draw it, we create a line 2D, which is a Java line. And then we populate it with the values from our points. And then we call the Java's version of draw on the line. So let's see if we can actually see a line on our screen. So we go over to our driver. Here's our main driver. Oh, I guess we're doing it in the component class. So here's our drawing component. Now we want to draw a line. So I'm going to say line, my line. Again, we're just following the same pattern as the other ones, equals new line. And we pass in values for x and y. So I would say 3 and 20, just random numbers. We'll call the draw method. And we'll pass in G2. Not liking this. Oh, we decided to make points, right? So before we can call this, we have to create our points. So we could say point so this is our first point. And here we'll put in our 3 and our 20. So that'll be our first one. And then we put in our second point. Again, I'm just picking numbers out of the air, so. And then we call the constructor now with our points. So to create a line, we create the 2 points, the beginning and the end of the line. And then we pass those points into our line method, creating, or a line constructor, creating a line. And then we're asking the line to draw itself. If I run it, there's my line right there. If I want to see it a little bit larger, I could increase x by 160 and y perhaps. So now we can draw lines. So all that work just to draw a line, yikes. But now we have all the basic building blocks to create pretty much any kind of polygon, because we have now a points classes, we have a line class, and it all looks pretty good. So these graphic primitives we're going to be using all through this course, talking about how to use them as ways of creating player objects, doing geometrical shapes that are kind of interesting. So now that we have a line, we have to go back to our original problem, which was the isosceles triangle. How might we specify that? Well, it's got 3 lines. It's got 3 points. We have ways of creating points now. We have ways of creating lines now. So do we have everything we need to draw a rectangle, or a triangle, I mean? Yeah, I think so. Okay. But I think our brains are about to explode. So we're going to wait. I want to give people time to think about this and start creating your triangle class. Where would I put it in our inheritance hierarchy? Well, for now, it's really not a regular polygon. Remember, a regular polygon, all the lines are the same length. Isosceles isn't that way. This bottom one can be any length. Okay, so it wouldn't really fit in there. So we're just going to take it right off of shape 2D. Because it needs to draw, it has an x and y coordinate, it has a width and a height. Because remember, we're defining the isosceles triangle based on a rectangle. Its bounding rectangle will actually create the triangle that we want. So the suggestion then is to make the isosceles triangle derived from shape 2D directly. So here's our isosceles. The compiler's complaining here because we haven't made our draw method yet. We'll do that in a second, but let's put in these constructors first. And this time we might pass in the 3 points as separate ones. So we'd say point P1, point 2, and point. Again, the patterns are always the same. You see how we created 3 classes today, but the process we go through is all the same. First you create your instance variables, then create your constructors, then after that maybe your accessors and mutators. But the pattern is always the same. As a class, we need to be able to create a class quickly because we always go through the same steps. Now, if this is getting past you and you're not understanding this, again, I'm making the video so that you can go watch it again. But if you do watch this video again, you'll be able to see this pattern where we create the instance variables, we create the constructors. Next, we create the accessors and mutators. Always the same. Now we have all the accessors and mutators. Last thing we have to specify is the draw method. So here we could say public draw or void. I think that we're trying to override the draw method on our shape2D class. And the draw method takes a graphics D. Is that right? I don't know. Yeah, it's not graphics 2D. It's called, I guess I have to look at the shape2D. Graphics 2D G2, yeah. Yeah, that's probably it. And so where we create the lines is right here in the draw method. We want to wait to create the lines until we have to. We need to do that when we draw it. There's no need to put the lines inside the iso triangle. All we need really is the points. And with those we can figure out everything else. So let's do that. So we would say this is our first line. Let's call it line 1. You have to be careful in this font. 1 and L look very similar, so maybe that's not the best idea. Let's just call it A1 then. Or just call it A. And again, this takes points to create the line, so we say P1 I guess it likes that. Side B, maybe go from 2 to 3. C. I'm not implying that this is the hypotenuse, but maybe you could read it that way. Here we complete the polygon by by doing that. Once we have all the lines, then we can just have the lines draw themselves. Now, since we've done the inheritance hierarchy pretty well, this doesn't take a lot of effort, right? We already know how to draw lines. Now here we draw 3 lines because we have a triangle. We create our 3 lines from the points that we have inside the class, and then we use those lines and have them draw themselves by calling the draw method on each of the lines. How can we test this? Again, we go back to our component class, and we'll draw a triangle. Say we want to call the default constructor, and then we're going to set the lines, or set the points after the constructor instead of passing them in. So we could say point P1 and say that's our first point. And then we can set the point. We can say my ISO set P1, and we'll pass in P1 as the parameter. And just do that 2 more times. Now this is going along William's idea about, instead of the bounding rectangle, we'll just go with the points. So this is a more generic, maybe, triangle class. We've set the 3 points in our ISO triangle, and now we can just draw it. And again, the code here in our component is just driver code. We're just trying to exercise it. We're not really doing anything with these shapes right now. We're just trying to see if they can draw themselves. Let's try this and see what happens. Doesn't look very triangular, does it? Let me get rid of that one line and see. So temporarily, I'm going to not draw this. Yeah. So I have P2, P2, P3, P3. So what are you seeing, William? Yeah, I keep setting P1 here. It should be P2 and P3. Okay, so let's try it now. Yeah, there's our triangle. Kind of weird. Is it an isosceles triangle? The answer is no. Okay. So how would we make this an isosceles triangle? Well, we could do all the math and try to do it here in the driver. But say we want to create a more specialized type of triangle, like an isosceles triangle where we're drawing it based on its bounding rectangle. That changes what we have here in our code. Let's go back to the iso triangle then. So instead of passing in 3 points, what we want to do is derive the points based on the size of the bounding rectangle. We know the iso triangle derives from shape 2D, so we can go and get these different values and create the points at this location. So we would say, well, point 1, let's make that one the top of the triangle. And so we would say get x, whatever the x coordinate is, plus, and this time we say get width divided by 2. And it complains. And then y is going to be just y. So that's our first point. For our second point, we decided that get x is, say we're doing the bottom left point on the isosceles triangle. We get x, and then we say get y, and we add the height in. And here we'll say get x, and we'll add on the width. And this will be the entire width this time. And y is going to be get y plus get height. Now remember, we wanted to define this based on the bounding rectangle. So here then, we would say and then we'll just call this super constructor here. We'll say super so the iso triangle is a shape 2D, and so for our get x and get y things to work out, we have to provide those values to the base class. So We set the top left coordinate x and y, width and height. First thing we do is we call the superclasses constructor, which is the shape 2D constructor. And then, since we just set those points, we can use or just set those values, and we can use them to create the 3 points in our triangle. Do we need this one here anymore? And the answer is no. In fact, we can, what can we do here? Let's just get rid of this one. Well, I'm hesitant to get rid of it. So maybe we do this. And we'll set these to we'll set these to null, meaning that if you want to create an iso triangle, we're not going to allocate memory for the points yet. We're going to leave it there at null. Trying to save some time here. So, does the draw method need to change at all? The answer is no, because we create the points right there. Let's try it again and see if we get an isosceles triangle. We still get that skewed triangle. The reason for that is why? When we create the triangle in the driving class, that's here. No, in the component. Instead of calling this one, we would say x and y, then our width, and then our height. Do we have to create these points now? And the answer is no. So it simplifies the code. So all we're doing is taking and saying, we're going to create this bounding rectangle. It's going to, top left corner is be 20, 30. It's going to be 50 wide and 100 tall. And I want you to draw my isosceles triangle. Okay? So now we have an isosceles triangle that we can put anywhere on the screen, and we can make it any size. So going back to the isosceles triangle then. We got to where we wanted to get, and that's the ability to draw an isosceles triangle, but it took a little doing, right? We had to create point classes, we had to create a line class. Once we had that, we can reuse what we've learned about shape 2Ds, provide the draw method using the equations we figured out earlier. So that's the process of taking a geometric formula and turning it into code. It's not easy, okay? It's difficult. You have to think about a lot of things. But anything you can calculate on paper like you would in math class, you can program on the computer. And this is the process of how you go about doing it. Now our assignment for next time, we won't have a lecture next time because this one's kind of long. I'd like you to draw a picture of a house, okay? The picture has to have a roof to the house. Just basically, if you were in first grade and you're drawing a picture of a house, you put a triangle for the roof, rectangle for the body of the house, maybe a square for the window, rectangle for the door. You might have the sun up in the sky, so that'll be a circle. We're trying to paint a picture then with our shapes. So think about that for next time, and then we're going to use all of these classes that we've created to make kind of a scene on the paper. And that'll bring us back to using loops, because the title of the chapter 6 was how to use loops. So how might you use a loop to create this scene with all these different shapes in it? And this is where it gets kind of interesting. So we'll do that next time.